Alright guys, in this session we're going to take a look at 5.8, Solving Inequalities. Now this is definitely going to be a new topic for you, so I want you to really keep an open mind, and I want you to stay positive, because this might seem a little confusing at first, but don't worry about it. We're going to have plenty of days to make sure that we get it, and I want you just to stay positive, okay? Take good notes and we'll start from there. Alright, so we got our symbols here, inequality symbols. So symbols you're going to use a lot of today, and you used them in your bell work earlier. The less than symbol, that's the top one, that's read as is less than. Anytime you say something, I always put it in quotations, okay? The second one is less than or equal to. That's why you have like half of an equal sign underneath the less than symbol, okay? The third one is greater than, that one you know, and then the fourth one is greater than or equal to. That means it could be bigger than it or it could be equal to it. Whereas you look at greater than, that means it has to be bigger than the number. It has to be bigger than what you're talking about. Okay? So these are the symbols we're going to be using today. And we're going to be talking about those in terms of answers. Alright? Make sure you have that all down before we move on. Alright, here we go. Alright, we are not just looking for answers today. Okay, we're not just looking for x equals 7, but rather we're looking for possible solutions or possible answers, because there's going to be a wide variety of correct solutions to our problems today. So you say, well, what is a solution then? Isn't that just an answer? So here we go. It says a solution of an inequality. So when you solve something today, is really any number that produces a true statement. Okay? So a solution is any number that makes the statement true. And there are many of them. So for example, we have x is less than 5. So possible solutions for x is less than 5 would be 4 or 3 or 2. And then you have those 3 dots after it. Those 3 dots indicate and everything less than 2. So what that says is possible solutions are 4, 3, 2, and everything else less than 2. Those 3 dots mean and everything else going in that pattern. And those are all possible solutions because they make it true. If you put those in for x, substitute that 4, let me get a marker here. If you substitute that 4 in for the x, it makes it true. 4 is less than 5. If you substitute the 3 in, 3 is less than 5. If you put the 2 in, 2 is less than 5. And if you keep going down the number line, 1 is less than 5, 0 is less than 5, -1 is less than 5. It works. So that's why you can use those 3 dots. So when you get an answer today, you're not going to get an answer x equals 7. You're going to get x is less than 7, and you're going to tell me, so x could be 6, 5, 4, ... Okay? And we'll show you what that means as we kind of work through our problems. Okay? Make sure you have all this written. Maybe rewind and watch it again. And let's move forward. So here we go. Alright, and the big tool to use today, and you may want to draw one of these on your paper, is the number line. Okay? Because it will help us picture our answers. Let's say we solve our problem today and we get that answer in orange there, x is less than 7. By using the number line, you can say, okay, there's 7 and I want everything less than it. So starting as the first number less than 7, I can list 6, 5, 4, and then ... to include everything else that's less than 7, including going into the negative side of the number line as well. So it's not just the positives. So x is less than 7, so it could be 6, 5, 4, 3, 2, 1, -1, -2, -3, and so on. Okay? So it's all the possibilities. Alright, let's see how this looks in a problem now. So we know what we're doing. We're using the less than symbols. Our answer is not just going to be one number, it's going to be all the possible numbers that work, and that we're going to use a number line to help us figure it out. So here we go. Alright, so here's our first example. Let's try this. X plus 4 is less than or equal to 6. Okay? Now, one nice thing about what we do today is that you already know how to solve these. You're just going to solve these like they're an equation. You're going to kind of hide the inequality symbol there, and you're just going to solve them like you would. You want to get x alone. So how do we get x alone? Well, we already know. We're going to subtract 4 from both sides. Draw your line. Okay? Just like we did the last couple of days. On the left side, the 4's cancel out, and I get x. I still have that symbol, less than or equal to. And then 6 minus 4, I know, is 2. Okay? So that tells me what range my answers are going to be in. They're going to be less than or equal to 2. All right? So here's our number line. We're starting with 2, and we want everything less than 2. Less than or equal to 2. So we'll start with x is, what do you think? 2, and everything less than 2. So what's next? 1, 0. And then what do we put down when we want to indicate everything else less than 0? 3 dots. Not 4 dots, not 2 dots, but 3 dots. Okay? In math, that indicates that the pattern continues. All right? What'd you think about that? Yeah, you already know how to solve these. It's just how you present your answer is how the difference comes in. Okay? You know how to solve it. It's just the way you present your answer that changed. Okay? Yes, and I will show you how this works in real life after we practice this skill today. So for those of you that are asking me, when am I going to see this again, Evan? Okay? This is when I'm going to show you the skill today, and I'll show you what it looks like in real life tomorrow. Let's try another one. All right. Well, one little reminder there about that less than or equal to sign. That means you have to include that number and then go smaller. Okay? Here we go. Here's example number 2. All right. Now I made this one look a little different. X is greater than x minus 2. Now, you cannot, we're going to draw our line here. Yes, you probably figured out, I'm going to add 2 to both sides. Yep. But you cannot flip these around. Last week, when we had an equal sign, we could flip these around. You cannot flip, okay? Because the inequality sign, the order matters now. The order of the problem matters, so you can't just flip things around anymore. Not unless you have an equal sign, okay? So, when solving this, we already know we got to get rid of the minus 2 to get x alone, so we add 2 to both sides. That cancels out. On the right side, I have x. I still have that same symbol. And on the left side, I have 16. I think we know that. Now, you have to read this problem going from the right to the left. You always read the problem starting with x. Okay? So if we read from the right, we're going to start with x is less than, because I'm going backwards now, right? 16. So that's read as x is less than 16. Everybody see that? Pause for a minute to make sure you know that. X is less than 16. I started on the right side of the problem and worked my way to the left so that I could read the inequality symbol. So when you want to read the inequality symbol, you always have to start where x is and go that direction towards the inequality symbol. So x is less than 16. So on a number line, okay, that's going to be anything less than 16. So 15, 14, 13, and then my 3 dots to indicate everything else less than that. Okay, here's our next one. All right, now you try this one. Let's see how you do. All right, there we go. 3x is greater than or equal to 12. You try it. Get some kind of answer. Doesn't matter if it's right or wrong. You just got to start your thinking, okay? All right, how'd you do here? This is like what we're doing later in the week. 3 times x is greater than or equal to 12. So we want to undo the multiplying. What's the opposite of multiplying? Divide. So we're going to divide by 3 on both sides. Draw your line. 3 divided by 3 on the left cancels. I'll get x greater than or equal to 4. So x has to be greater than or equal to 4. So thinking of your number line, there's the 4. We want to be greater than or equal to 4. So what are your solutions? Yes, 4, 5, 6, and dot, dot, dot. Okay? Did you get that? If you forgot the 4, remember that's a greater than or equal to symbol. Alrighty? Alright, here we go. Moving on. Here's our last example before the mastery. I just took all the numbers and symbols and wrote them in words. Okay, so we're getting used to some of the vocabulary and the terminology. Alright, take a minute to write this down before you try to progress any further, okay? Here's the problem. That takes a little while to write out there. And yes, it has some decimals in it. So let's see if you can write this problem out. 5 plus x is greater than or equal to 19 3/10. So remember what I said, when we solve these, we want to solve just a few words at a time. So start with 5, that's a 5. Then we have plus, plus. Then we have x. Then we have is greater than or equal to. So last time we said is means equal sign, but this is more than an is. It has that phrase, is greater than or equal to. Oh yeah, I need a greater than symbol with half of an equal sign. Okay? And then what comes after that? Well, another number. What is that number? 19. But then it says and. What symbol represents and? It is the decimal point. And then 3/10. So there is our actual problem. 5 plus x is greater than or equal to 19.3. Okay? And we want to solve this problem. So what do you think our first step is? Yeah, we're going to undo the plus 5 with minus 5. Okay? Drawing line. The 5's cancel out. I have x on the left is greater than or equal to on the right, and then I got to solve that decimal problem. Remember, where's that decimal point on the 5? Yeah, it's right after it, right? I'm going to try to write that down. It doesn't want to write. Let's try it again. There we go. Okay? And when you subtract decimals, you want to line up the decimal points. So we would do this. Okay? Do your subtraction. 14.3. And there's our answer. X is greater than or equal to 14.3. So what are the possible solutions for this? Something that's greater than or equal to 14.3. Now here's the only difference. When you have decimals, you can only go up by tenths, not by whole numbers. So we want to start with our original number, 14.3, because it was greater than or equal to it. And then we want to go up by tenths. So the next number would be what? 14.4. Good. And then 14.5. Good. And then, of course, dot, dot, dot to finish it out, right? Including everything else 1/10 bigger. So when you have decimals in the answer, your solution should go up by decimals as well, usually by tenths. Okay? The lot that we did here today, most of it or all of it is brand new to you, so don't feel too confused. We'll take it slow. We'll take it one step at a time. Let's try this mastery here. Okay? Do your best. No one's looking for perfection here. Here it is. We have x plus 7 is greater than 2. Ooh. What could that be? All right. I want you to do your steps, come up with an answer, and make sure you have all the possible solutions to the answer. Okay? And good luck.